everyone. Maintain silence. Keep quiet. Open your chemistry notebooks quickly. Last 2-3 benches. Last 2 benches, get up and come in the front. Quickly. Only take your notebook and come in the front. Yes, girls also get shifted in the front. Don't sit there. One, two, three, four. 4. Come here. 2 of them come here. 2 of them you can come here. Camera. Yes, get shifted here quickly. वेळ घालवायचा नाहीये, पटकन यायचंय. Okay, so here everyone. Yes, second last bench. What is your name? Yes, stand up. What is your name? Soham, be quiet. Yes, come in the front here on the third bench quickly. And along with the Soham, you also come here and join here. And last bench, get shifted in the front. Yes. So here in the last period, we had learned about the electrons, discovery of electrons, protons and neutrons. Right? That was a very, very important discovery which proved that there is a presence of a subatomic particles. Right? Or we can also call those particles as a fundamental particles. Remember, sometimes in your question paper, the question may come that what are fundamental particles? Remember. Right? So in that case, fundamental particles are nothing but electrons, protons and neutrons. Right? And what does the charge electron carries? The relative charges are electron carries a negative charge, proton carries a positive charge and neutron carries a zero charge. Right? That means they are neutral in a nature. Right? So everyone should remember this charges. Then we had also seen the masses also. We have seen the masses in the AMU as well as in a kilogram. Right? AMU stands for atomic mass unit. Right? So we have seen the masses of electron, proton and neutrons. The only thing you have to do is you only need to remember that. Right? Don't need to by heart that. And it is very, very easy. You can easily remember those particular numbers. Okay? As I told you yesterday also, that in chemistry you will come across with many kind of numbers, right? Especially numbers related to your atomic number, atomic mass, right? Then there might be any kind of a particular masses of a particular isotopes. So in that case, you people need to remember those particular masses, but don't need to by heart it, okay? Okay. In today's lecture, we are going to talk about the discovery of radioactivity, right? So you can note it down. You had already done that? Yes. Okay. The next point, effect of electric and magnetic field, get it? Effect of electric and magnetic field on radioactive substance. On radioactive substance. Effect of electric and magnetic field. Effect of electric and magnetic field on radioactive substance, on radioactive substance. Okay, next point, write down. In order to see this effect, of electric field, experiment was conducted. Okay, so what was that experiment? The experiment was very, very easy. Now I will show you the experimental setup. The experimental setup is very, very easy. What they have done in this case, they have taken a one lead block, and in that lead block, they have taken a radioactive substance. Right? That radioactive substance can be anything. It can be uranium, it can be polonium, it can be thorium, or it can be any kind of a radioactive source. Right? And what is radioactivity? In the yesterday's class, I gave you the meaning and definition also. So what is radioactivity? Radioactivity means are those substances which can emit the radiation on their own. Right? यानी कि जो अपने आप से रेडिएशन इमिट करते हैं उनको हम लोग क्या बोलेंगे? रेडियोएक्टिव सब्सटेंसेस बोलेंगे. And who proved this? It was proved by the Henry Becquerel. What kind of experiment was conducted? He conducted a very, very easy experiment. Rather, I will not call that as an experiment. It was not an experiment. But what he did, he took one foil paper. On that foil paper, he placed the radioactive substance, and above that, he placed the photographic plates. And it was kept in the drawer where the sunlight was not there, but still, after few days, when he took out from the drawer that particular sheet, he found out that on the photographic plates, there were the radiations were seen on the photographic plates. So it was proved that radioactive substances are those substances which has the ability to radiate the particular radiation on their own, right? Without undergoing any kind of a chemical process. समझ में आ गया क्या बच्चों? So this is what was conducted. अभी इनको देखना था कि अगर इसके ऊपर इस रेडियोएक्टिव सब्सटेंस के ऊपर अगर इलेक्ट्रिक फील्ड लगा दिया तो what will happen? So they conducted an experiment. In this experiment, what they did, they took a one lead block, and in this lead block, they placed the radioactive substance. So this is a radioactive substance was taken, and this is a lead block, right? So why lead block was taken? The reason for taking the lead block was so that any particular radiation, if it gets emitted over here, or here, it may get easily absorbed, right? So they wanted to conduct the experiment very properly, so that the emissions which are there from the radioactive source should not get emitted or scattered everywhere, right? So what they did, in the front, they placed one slit. राइट अभी स्लिट का मीनिंग क्या होता है? स्लिट मतलब जाली. एक जाली लगा दिया उन्होंने एंड दे कंडक्टेड द एक्सपेरिमेंट. राइट आफ्टर सम टाइम दे फाउंड दैट सम ऑफ द रेज वेर पास्ड थ्रू दिस स्लिट, एंड हियर दे हैड प्लेस्ड द फोटोग्राफिक प्लेट्स. उन्होंने क्या किया? यहाँ पे फोटोग्राफिक प्लेट लगा दिया देखने के लिए कि ये जो रेडिएशंस इमिट होते हैं ये कैसे ट्रैवल करेंगे, राइट? सो व्हेन द पर्टिकुलर रेडिएशंस वर इमिटेड, इट पास्ड थ्रू द स्लिट एंड देन द इलेक्ट्रिक फील्ड वाज अप्लाइड हियर. द इलेक्ट्रिक फील्ड वाज अप्लाइड हियर. व्हाई यू आर लेट? This is for the last year. Next time onwards, I am not going to allow. Enter. Okay, so what he did, he applied the electric field, right? And he found out that some of the radiations were deviated from this side, and some of the radiations deviated on this side, right? let's say this is a negative terminal and this is a positive terminal, and some of the radiation passed on the photographic plates. Now, see, this was very interesting. सबसे पहले तो हमने ये पढ़ा था कि रेडियो एक्टिव सब्सटेंस के पास ये एबिलिटी है कि वो रेडिएट करेगा, right? But now we found out that it only doesn't radiate, but it gets attracted towards the electric field. Then he called those particular rays, ये जो rays है जो नेगेटिव के तरफ जाते हैं, those were called as the alpha rays, and the one which was deviating towards the positive were called as the beta rays, and the one which did not get deviated anywhere else, those were called as the gamma rays. So are you understanding, my dear students? This was a very easy experimental setup, right? Okay, next point, write down. From the experiment it was proved, that the rays produced were attracted towards, from the experiment it was proved that the rays attracted towards the electric field, The one which was attracted towards negative terminal, were called as the alpha rays. The one which was attracted towards the negative terminal were called as the alpha rays, and the one which was attracted towards the positive terminal, second pointer, the one which was attracted towards positive terminal were called as the beta rays. Right? And third point, and the one which did not get deviated, and the one which did not get deviated, and the one which did not get deviated passed through the photographic plates. बराबर है ना? जो डेविएट नहीं हुए वो क्या हुआ? They passed through the photographic plates and they were called as the gamma rays. So write down, they were called as the gamma rays. Okay, so we have learned the discovery of electron, discovery of proton, discovery of neutron, and then we had learned the radioactivity and then the effect of electric current on the radioactive substance, right? So these four concepts are over. Now write down the next concept. Diagram you can look it into a video when you go home. घर पे देखो, video open करो and then draw the diagram, right? We will not waste the time now. Okay, note down. Concept of atomic number. Concept of atomic number. Atomic number was first introduced by Henry Moseley. Or you can also call it Henry Moseley. right? Next one, write down the total number of atomic numbers is equal to the number of protons present. Atomic number is equal to total number of protons present, right? So this is a very very important equation. You all should remember. जितने atomic number है, उतने total number of protons होंगे. Remember this, right? So atomic number is taken with the help of a protons. Are you understanding? Everyone should remember this in chemistry. जितने protons होंगे, उसका ही उतना atomic number होने वाला है उस particular element का. Okay, next. Representation of element. So do you remember in my basics class, I already told you how to represent the element. Element is represented by the X, and above X we write the A, and below X we write the Z. बराबर है ना? So what is the reason for writing the X? What is A? See, A stands for atomic mass and Z stands for atomic number and X stands for, समझ में आ गया बच्चों? तो you open the periodic table and you can see that the representation of the element is always given like this in the periodic table. You take any particular element from the periodic table, you will see that the elements are represented in this way. Okay? समझ में आ गया सबको? For example, अगर हमको लेना होगा तो कार्बन का ले लो. Carbon 12 and 6. So what is the 6? What is the 6? 6 is the atomic number. उसको हम लोग क्या बोलेंगे? Z equal to 6. Okay? Then what is the 12? Atomic mass. So A is equals to 12. समझ में आ गया बच्चों? So this is how we represent the element. So A is nothing but the atomic mass and Z is nothing but the atomic number. ठीक है? समझ में आ गया? Okay, next. Take the examples. I will give you few examples. Let's see how you people can represent the element. Oxygen. Number 1, oxygen. Number 2, chlorine. Number 3, sodium. Number 4, magnesium. And number 5, boron. Come on, try it. I'll give you 2 minutes. मुझे representation दिखाओ कैसे करते हैं elements का. I want the atomic number, atomic mass at the top and atomic number at the bottom. Yes, who can tell me the atomic number of magnesium? What is the atomic number of magnesium? 12. Very good. Not 16. चलो, atomic number 12 है. What will be the atomic mass? Yes, open the periodic table. What is this page number? Page number 271. Everyone, open the page number 271. Yes, here class. Everyone, maintain silence. Yes, quickly tell me the answer. Who can tell me the answer? चलो बोरान किधर है देखो बोरान एटॉमिक मास देखो उसका क्या दिया है Who can tell me the answers quickly? चले तुझे चला बोला. Here everyone, be quiet. First bench, be quiet. Yes, come on, tell the answers.
Oxygen 8, fluorine 17,
Yes.
sodium 11, magnesium 12, boron 5.
Okay, very good, very good. Sit down. Anyone else who can tell me the atomic mass? Come on, quickly. Who can tell me the atomic mass now? Shreyash. Tell me the atomic mass. Okay, anyways, I hope that you all have done it, and if you have not done it, remember you have this in your periodic table. Everyone, pay attention here. You can take out your textbook, third bench, fourth bench. Listen here. You can take out your textbook and on the page number 271, today itself, whichever element I have given, you go home and properly see the atomic masses and the atomic numbers. Okay? Okay, next point, write down.